All right, if you've not already watched question 7, then 8, I would strongly recommend starting with that. It says, give the 4 quantum numbers of each of the circled electrons below. So here we have the 2p orbital. So from before, we have, this is n, and this is L. And what I should have started out with is, to find the 4 quantum numbers, we want to find n, L, m sub L, and m sub S. Okay, so these are the 4 quantum numbers we're looking for. So this is n2. L is based on a p. Remember to translate. L equals 0, we call that an s orbital. 1 we call a p. 2 we call a d. And 3 we call it f. So because here L is equal to a p orbital, L has to be equal to 1. Now, there's a tendency to think that, well, if this is 2, L could be either 0 or 1. How do I know it's 1? Well, it's 1 because it's in a p orbital. Remember, any individual electron, like this circled electron here in this 2p orbital, has 4 unique quantum numbers. It doesn't have 4 sets of quantum numbers. It has 4 individual quantum numbers, just like you have a time, a longitude, latitude, altitude, and time that describes where you are. An electron has 4 unique quantum numbers that describes where it is, or where it's likely to be. All right, so here we have n and L. How am I going to find m sub L? Well, what we do is, what are the possible values of m sub L based on an L of 1? They're -1, 0, and 1. Remember that a p orbital has 3 orbitals. I see 3 p orbitals here. There's the -1, 0, and 1. So I just labeled them from left to right. The circled electron is in the -1. M sub S is, up is plus a half, down is minus a half. So this is plus a half. Let's do it again for this one. N, L, m sub L, m sub S. Again, each individually circled electron has 4 unique quantum numbers. It does not have a set of quantum numbers. So here we have the 5s. So we can translate, this is n, and this is L. So n is 5, L is 0, because S is 0. You'll note that there's only one s orbital. So the m sub L of this s orbital, or any s orbital, has to be 0, because there's only one of them. With the p, there's 3, so you could have the -1, the 0, and the 1. With the d, there's 5, as you'll see in a minute. But here, there's only one possibility, which is 0. This electron happens to be spin up, so the spin up makes it plus 1/2. Let's look at the last one. We have a 4d, so we want to find n, L, m sub L, and m sub S. So how are we going to do that? Well, 4 is the value of n, and d tells us L. Again, we have to translate. D is in L equals 2. Now we need to find the m sub L. Well, what are the possible values of m sub L if L is 2? -2, -1, 0, 1, and 2. Said another way, there's 5 possible values, and there's 5 orbitals. Okay, these two things are related. So -2, -1, 0, 1, and 2. I just labeled them from left to right, because that's just how I do it. All right, then we have this 1 for this particular circled electron. Again, they're all up, so again, m sub S is plus a half. If you did have an electron pointed down, if this one were circled, then this would be -1, and this would be minus a half if that electron were circled. Okay, so that is basically how it works.